Okay, in this video, I'm going to go through how to go about making exponential graphs for your temperature data. All right, so each of you should have a sample that might look something like this, where you've got a 3 time series with temperatures for 3 different temperature rooms. All right, we need to do a bit of transformation on this data, and then we'll go about doing the graphs. Okay, or alternatively, you might have been the group that did different containers, so Coke can, foam can, glass beaker, or plastic. All right, so you probably have 4 series. All right, let me explain a couple of things about these data sets, how they came to be in your samples. All right, so I went and combined the different data that I was given. Couple of goals that I had was to make all the initial temperatures the same. So I had to crop some of the early values. All right, and then I also went through and I made sure that the timing was ends about the same. They're not entirely consistent in terms of what time is in the correct row. This one is pretty good. But when I went through the other one, I noticed that there was a few gaps. So the increase in time wasn't consistent. But it doesn't really matter so much, so long as it the temperature at the start's the same and the total time's the same and it starts at time equals 0 or approximately that. You might notice that a couple of your columns don't start at time equals 0, but they start at a small time, like 5 seconds at most. All right, that's fine. Okay, but you have access on your sample. The other sheets will actually have pretty much everything that was initially, all the initial information, and the worksheet I used to figure out the samples to begin with. So you're all going to, if you're working on the same stuff, so you're working on the different cup types or the different room temperatures, you have different but similar results. Okay, so let's go through. All right, so let me just show you what I've done here. So this is the goal, so outlining the goal. One goal is I'm going to get you to work out the temperature difference. All right, so you need to subtract, because of the way exponentials work, exponential modeling in particular, is you need to model such that it approaches 0, not approaches any other value, which means that if you've got for example, a 31-degree room, the data is going to trend towards 31, not 0. So what we're going to do is we're going to subtract. I've done that over here already, but I'll demonstrate this again in a minute. All right. We're also going to change the time from seconds to minutes. That's something just to make the modeling a little bit more manageable. You might notice if you zoom in a bit, maybe, I don't think I can actually zoom this. Does it? No. Oops. No. Oh yeah, there we go. So you notice that actually this one that's in seconds, you've got a whole bunch of zeros in your decimal place. That's tricky to manage. So in the one I did below that, where I converted to minutes, all right, that's a lot better. It's only got 0.0, then it's non-zero numbers after that. All right, I'll show you how to go about doing that as well. Okay, all right, so I think I'm going to go and I'm going to pick a different sample and I'm going to start over. All right, so first things first, all right, I'm going to make a little bit of space there. All right, I'm going to go and I'm going to put the minutes. Actually, no, you know what? Change my mind. I'm going to put the minutes to the right of the seconds. It doesn't really matter, it's just the way it looks out. Okay, so we're making a new time column. So all I did was click on this, the B, and I said insert. Right-click insert to do this, just to keep things organized. All right, so I'm going to do time minutes. Okay. Now, some of these shortcuts and things that I do may not work in your version of Excel. There might be some other technique. Also, if you, I know a bunch of you use Macs, so that might be a bit different too. All right, so To convert from seconds to minutes, start with an equation, so press equals. Click on the element, so the first time, and we just do /60. Divide by 60, enter. Okay, so we've done the first one. Okay, now, if you're not familiar with Excel, there's a few tricks of the trade. One of which is if you hover your mouse over the bottom right corner, okay, you can actually drag and repeat a command. But we have lots and lots and lots of data. There's another way to do that as well. If you double left click, it should also do the same thing. So double left click, and what it's gone and done is filled the same thing. So if you look at what it's done, it's gone and divided each of those seconds by 60 to convert to minutes. All right. So now we've just converted the time to minutes. The next transformation we need to do is we need to change the temperature data. So we're going temperature, temp, above, room, temp. Okay. All right. So the way to do that, again, start with the equals, click on your temperature data, and subtract your room temperature. Now, if you've done different rooms, the room temperatures are mentioned in the data above here. So you see 22, 15, and the first one, I've subtracted 31 because that was the room. If you got the other data, you have to use the room temperature of the lab that we recorded on the day. I'll come back to that later on. All right, but effectively, all these steps are the same for the same data, so I'm not going to do it twice. All right, so once again, okay, so we've now gone from 74 to 43. So while these have very similar initial temperatures, they're going to have very different temperature above room temperature to start off with because they're in different locations. That won't be the case for the one with the different cups. You all start at the same temperature above room temperature for each of them because that was a controlled variable. All right, again, double left click, and it should carry out all the calculations for the temperature above room temperature. All right, so you would repeat that. I'm not going to do it again, but you repeat that for all of them. But I'm going to move on to the next step, which is to carry out a chart. All right. Now, for time series data, line charts can be done. I prefer just in general, because of the nature of what we're doing with this, we're going to do scatter plots. So go insert chart, so insert scatter plot. We'll do one that doesn't have lines. Okay. All right. So I'm just going to insert it like that. I don't like to use the highlight method where you just highlight and do a chart. It's a lot of messing around. All right. Then right click, select data. Okay. All right. Now, okay. Then click on add. So you can display these all together if you do it in this way, like you do 4 of them. I'm just going to do one so I can get the exponential equation. All right, so this is going to be temp, series name, I just want to type it. Temp above room temp. Okay, X series values. All right, and then you can go and highlight the minutes. So I might just go and click on this and see if that works. So I just clicked on the column. I haven't actually tried it that way before. I did it by dragging, but that takes a long time. Then go to your Y, delete the 1, and just put the equals in there, and click on the one that has the temperature above room temperature. Okay, so that's my column B, my column D. I might have to delete the, okay. Yeah, that's not going to work, unfortunately, because I've got a little dent there. That's recording the labels, unfortunately. So I might have to edit that. All right, so sorry, I'm not doing it that way. Changed my mind. Okay, I will have to drag. This is a bit tedious. So drag. I'm sure there's a faster way, but I'm not too sure. Okay. Okay. And then do the one with the temperature above room temperature, which is this one. Just don't include the label. Okay, there we go. All right. So temperature above room temperature, got that. All right. So things you need to do now. Okay. Reduce to okay. Got that. All right. So you see your graph is very chunky. The reason for that is because you got loads of data points. An optional way to approach the assignment later on is make your sample even smaller. Like do every 10th value. Because you notice in here, you're getting very similar temperatures. If you look at your temperature data, like it's minutely changing. Even at the start, you're changing by a third of a degree. But that's up to you. This is an issue with the way it displays, but there's a few ways to approach that. Okay. All right. So click on in this version, I'm going to click on the plus sign. I'm going to add axis labels, and I'm going to add. I'll do the trend line in a minute. Okay. Axis labels. All right. Temperature degree C. Okay. All right, and that's if I can highlight the degree. Come here. So little. All right. Control Shift equals. There we go. Superscript. Awesome. All right. Axis title. Okay, is that one's time. Delete. Oops. No, thank you. There we go. Cool. So I nearly deleted everything. All right. That is now time in minutes. Okay. Probably should put brackets around both of those units. I'll do it later. Okay. All right. Now, so that's just a label. Okay, next step. All right, we want the equation. All right, so we're going to go into trend line, tick that one, and then go across to that. And I'm going to go into more options. All right, there we go. Okay, so we want an exponential. And all right, we want an equation and we want r squared. So get your head back to what we were doing a few months ago. Okay. All right. And it pops up over here, unfortunately, but we can drag, that's fun. Okay. Now let's just zoom in on that a little bit. There's a couple of issues. All right. One is, okay, there's an inconsistency in the decimal places. Well, actually, no, that's the problem. There is a consistency in the decimal places, sort of, but if you have small and large values combined, so we got nearly 40, and this one's 0.031. Even though we converted to minutes, I've only got two non-zero digits there, so 3 and 1. I want to make that a bit bigger, so I want to have about 4 significant figures. What that means is I'm going to have to increase all my decimal places and then round off. I'll show you how to do that now. Okay, so what you can do is right-click into... Nope, not that menu. I think I might have to right-click on this. Format, trendline, label. Okay. Okay, so we're going to go into number. And we're going to go decimal places. So if you look at this, I want my number next to the x, the power coefficient. I want to have at least 4 non-zero digits. So I'm going to go to 6. See what that does. Okay, you're going to apply that. Right, there we go. Okay, one less, 5. Enter. Yep, there we go. Okay, so now you got, it says 0.03118. All right. And then I actually don't need that anymore. I've got everything I need. I'm just going to round off the other ones. So you can do this rounding manually just by deleting numbers and rounding if you have to. So if I actually yeah, that's fine. I delete those. Actually, what was that? Was that larger than? No, this is 4. Okay. So I'm just going to round off everything to. This is called significant figures, not decimal places. I just want 4 non-leading zeros. Not leading non-zeros, I should say. So if it starts at if it's a 0 point something, I want the first digit I count to not be a 0. All right, and then delete. Okay, I need to round that one up. Okay, All right, so then that's more consistent. So I've got 4 cent figures, 4 cent figures for all of them. So for the coefficient, for that k value, and for x. Okay, so now I've got a graph, I've got a model attached to that graph. You might notice you also get a linear. I'm just going to delete the linear. Another issue is because of that fatness of the line, which you can probably edit in the settings, you can't really see the exponential model too well. It's over the top of it. You can kind of see there's little points where it's featured. I'm sure there's ways like you change the color or something. You can work it out in some of the other options. I'm not going to bother with that right now. Okay, so the last thing is I'm going to convert that equation to. Okay, let's make ourselves a bit of space. All right. Actually, how am I going to do this? All right, let me just move that over a bit. Share my screen. Okay. All right, move that graph over. So I just want to see that number while I'm working. Let's make sure I got it right. Okay, so we're going to convert that. Okay. So this is the last step I'm going to record. All right, so if I got that. So I've got, I want to go from, this is the formula called a e to the x. Should have my mouse while I'm doing this. Can I actually write on here? Yes, I can. Excellent. I'll just use my fingers. Easy. All right. So what I want to do is Excel uses this method. It uses y equals a e to the k x as its method. E, let's pull up our calculators. Do a question or? Okay, I'll just pause it. Okay. Yep, and pause. I don't think I actually paused that properly. Okay, I don't even know that pause right. I might have to edit that. All right, never mind. Alrighty, so okay, so in terms of this, okay, so what is E? E is a number like pi. It where is it on this calculator? I keep mixing it. All right, it's there. It's one spot. It's also in your. Oh no, it's just there. Okay, it's in your. It's a second of your divide sign. Okay, so if you do e to the power of 1, okay, it's that's what the value actually is. Why is that important? Not really important at all for you guys. It's if you go talk to your friends in methods, e is used for exponentials because it's very convenient for calculus, which you don't do. All right, but it's a transcendental number that has no ending like pi and square roots do. Okay, but okay, we did our exponentials like this. So we did y equals a b to the power of x. That's how we did it. Okay. How do you convert them? All right. So all you have to do to work out your b value is work out your ek value. All right. So in this case, my ek is e to the power of minus 0.03118. Okay, so I'm just going to put that in my calculator and figure out what that is. So again, e to the power of negative 0.03118. Okay, execute. All right, so then, all right, that is the value for B. This is also another, from memory, this is also the reason why I picked to change from seconds to minutes, because if I don't, you end up with something that just goes 0.99999 for a while, and it's not easy to work with. All right, so then, okay, let's make it a little bit more space. So then my model All right, so then I can write my model as y equals, what was the other value? All right, 39.81 times 0.0, so we get a 0 in there, 0.9693, that's 4 significant figures, to the power of x. So now what I've gone and done is I've converted the model that Excel gave me, that one up there, to the